Hi, I'm Zoe Poppert, and I'm planning on majoring in mechanical engineering with a focus in mechatronics so that I can eventually get a career in the robotics field, and this is my final project. This is the structural system I'm analyzing. It is an eyelash curler, and it is with me here in my UMD dorm room. The machine is fairly simple. It consists of a top handle and a bottom handle. The top handle is connected to this backing, and the bottom handle is pinned to the top handle so that it can rotate about it and cause these rods to push this clamping piece along this sort of track and push into this backing. And the eyelashes go between these two clamping pieces and they get pinched in the middle, and it gives them a more curved shape. I think the system is interesting because it has similar components to some of the things that we've analyzed in class, but it also has some new things or puts them together in a different way. I also just think it's cool because it's something that I have, something that I've used, and it would just be interesting to understand more about the way that it works. The units that I chose to analyze from Category 1 were force vectors, rotational forces and moments, and free body diagrams and structural supports because of the pin connections. And I used all of these to draw, analyze, and understand the forces that were acting on the eyelash curler so that I could do calculations and draw conclusions about the subjects that I selected from Category B. The first subject that I selected from Category B was stress and strain, which I applied in both calculations regarding the failure from shear stress in the pins and the stress all over the metal plate. To calculate the failure from shear stress in the metal pins, I set the shear strength of stainless steel equal to the reaction force at the pin, each of the pins, which I divided over 2 because they're both in double shear, and I divided the pins cross-sectional area, which was different for each, and then calculated the applied force from that reaction force at the pin. To calculate the stress on the metal plate, I just divided the force on the clamping metal piece over the cross-sectional area of the metal piece. Another unit that I chose to analyze was the mechanical advantage because the leverage from the handles would cause there to be one, and I was curious how large it was. So I did this by using an arbitrary input force and calculating what the output force would be from that input force, and then dividing the output force by the input force. The main thing that I wanted to test in this analysis was when the system would fail. So I wanted to see how much force I could apply to the system before pin A or pin B failed from shear stress. And I found that it would take 391 newtons of force applied at the handles in the center here for pin A to fail. And that's this larger pin here. It's got twice the diameter of pin A, which is this smaller pin. And pin A would fail after only 118 newtons of force were applied at the handles, which is not surprising because it has a much smaller diameter. So it is more susceptible to failure because of shear. I found a research paper that said that the average force that male subjects were able to exert with their middle or index fingers was about 55 newtons, and the average that they could exert with their thumbs was 108 newtons, which is less than you would need to shear the bolts if you're holding the eyelash curler like this. However, if they use their entire hand, the average maximum force that the men could exert was 550 newtons, which is well over the force required to shear the bolts, meaning that if someone grabbed the handles like this with their entire fist and squeezed as hard as they could, then maybe they could cause the bolts to shear. And I think this makes sense because it's like a thin, inexpensive machine, but I am kind of surprised that someone would be able to break this with their bare hands. I would test that to show when it would break, but I do want to continue to use this eyelash curler, so instead I created this very realistic demonstration of the failure.